Hey y'all, it's Mr. N here with the first lesson of the year. So we're going to be doing this a little differently than we've done in the years past. Some of you did have me for math, and with Miss Esquivel, a lot of the lessons were on the whiteboard during the day, making you guys pay attention, only having one opportunity to really see the material. This year I figured I'd change it up a little bit and give you guys some video lessons so that we can have more time to explore the material during class, and you can actually have this resource on Google Classroom if you're ever confused by any or unclear about any of the things that we're talking about or using in these activities that we do. So the first thing we need to cover in Algebra 2 are functions. So I'm going to just give us a good title, Lesson 1, Functions. This is going to help out quite a bit with the functions machines activity that we're going to be doing, that we should actually be looking at already. So first off, defining a function, it's where we have one output for each input. So the first thing you should be wondering is, well, what's an output and what's an input, and what does this all mean? So we can think of it, we can simplify it starting off with just two numbers. I'll make the first one 3. And so we can call this 3 an input. Reason why we do that? We can call this the function machine. I'm going to make it a box. Probably have a cooler looking picture going on your worksheets. But as you guys know, I'm not that great of an artist. So don't worry about notation for now. Just know that this symbol right here is a function that we put a value into. So we're going to put a 3 in there. So the 3 goes in. That's why we call it an input. And maybe for this specific function, what comes out is a 5. And you guessed it, we call that an output. So putting in a 3 goes through a set of rules, comes out as a 5. So we can do that more and more, and what I want to do is take a step back. I know I verbally said what a function was, but I want to put it into writing. A function is a very special case where you have each input gives exactly one output. So notice for in the case of the 3, we put in a 3, we get a 5. So if we want to define a function, we actually have to have more than just one input and one output. We want to test a few. So maybe we have this function, we decide to test the 0 and put it into our function box. And what comes out is a 2. So each input gives exactly one output. And maybe we do a 4 now. We put our 4 into our mystery box and out comes a 7. Still a function. We have one input 4 giving one output 7. So before we jump into anything else, I want to kind of show you what a function can look like. Let's look at f of x, our function that we put our input into is going to be equal to x minus 2 squared. So even though we haven't gone over the specific form yet, we can use our tools and we can use our ideas that we've been going over in Algebra 1 and even before that to figure out what our output would be, what would come out for our f of x if we were to put in different values for our x. So this is where our x, y tables are going to come in. And remember, you can choose whatever values you want for our x. What I'm going to do is wrap it right around the 0 point of our x so that we can have smaller values going on here, so it's easier to calculate what our outputs would be. So let's start off with this -2. Why not? Start off with the hardest one first. So just like up here where we were saying, hey, we have an input 3, we're going to throw it into our function and an output will happen. Well, in this case, what this table is saying is I'm putting a -2 as my input into this function box that's defined by x minus 2 squared. So notice how our x is equal to -2 here. So if we wanted to put it in our f of x, notice how I'm going to, again, notation, all it is, our function when we put -2 can also be seen as -2 minus 2 squared, okay? So we can simplify this. -2 minus 2, remember we're going to go more negative, so -4 squared, which actually comes out to -4 times -4, which in this case is equal to 16. So when we put a -2 into this function x minus 2 squared, what we're going to come out with is a y value equal to 16. So that's the first part of our table. And we can actually do this over and over and over again. Maybe we want to check out x equals -1 now. So we have our function evaluated at -1. So we're looking for the output when the input is equal to -1. And that's equal to, looking back up at our example, -1 minus 2 squared. Or simplified down to -3 squared, which is just -3 times -3, and that'll give us a 9. So for our table, when we have an input of -1, we have an output of 9. So I'm going to leave the last 3 for you to verify, but turns out when we have an x equal to 0, our output y is equal to 4. When our input is 1, we put 1 into our function. We're going to have an output of 1. For 2, we have 0. And actually, we're going to do a few more just to we're going to graph this a little bit. So maybe we go out to 3, and we'll find 3 is equal to 1. Why not do one more? So 4 is going to give us 4 as well. So we have our inputs, we have our outputs. This last step of review is going to be actually graphing something. So I'm going to give us a nice little border so we can have a good amount of space. So we are going to individually graph these. So remember, this is called a coordinate plane. 1, 2, 3, 4, 5, and then maybe 1, 2, 3, 4. And then we're going to go up, let's say 5 spaces. 1, 2, 3, 4, 5, or 5 units rather. So I know it's been a long summer, but just to review, we have our x-axis. You can call this the independent variable. And then the y-axis is called the dependent variable. And the reason why we call these independent and dependent variables is pretty obvious once we look back to our table. Notice how we chose our -2, -1, 0, 1, 2, 3, 4, x. It was independent of anything. We decided those were the numbers that we wanted to choose. But the y variable is the dependent variables. It depended on the function, and it depended on the x value in order to get these y values. So all we got to do now is graph some of these out. So I'm going to go ahead and skip over the -2 and -1. The reason why I'm doing that, well, think about it. It's going to be pretty difficult to graph a vertical shift of 16, given that I only have 1, 2, 3, 4, 5 units that I can go up and down. But if I move over to my 0, well, it's saying go 0 steps right along the x-axis and go up 4 steps in the y-axis. So we start at our origin, we don't move left or right, and we go up 1, 2, 3, 4. So that is our first point of our function. And so what we're doing here is kind of figuring out what this function looks like when we put it onto a coordinate plane. Remember, this is our coordinate plane. Okay, so let's keep going through this. We have an x value equal to 1, which is going to give us a y value equal to 1, or rather an input of 1 gives us an output of 1. So we go over 1 step, up 1 step. There we go. Now we have our 2, 0, so we step 2 units on our x-axis. Don't go anywhere on our y-axis. We go for this next one, 3, 1. We're going to go 1, 2, 3 steps over, and then 1 step upwards. And then finally we have our last point here, 4, 4. So we go over 1, 2, 3, 4 steps, and then up 1, 2, 3, 4 steps. So one other thing to know, and that I really want to be explicit about, is this idea of a line or a curve, or what this is called a parabola. Why we make it a solid line. And you have to think about it in terms of all our different inputs. If we're looking at our x values, there's a lot of numbers in between, even 0 and 1. We could have 1/2 or 0.5. We could have 0.1 or 1/10. We can have the tiniest number, and it would still have a corresponding output. So this rule doesn't just hold true for whole numbers. We can go anywhere in between this x-axis. So once you have a few of these critical or crucial points down, you can kind of start seeing what the pattern is for our parabola. And if we kind of see that trend, we actually see how at -1, we're going to be way up here at 9, and then at -2, we're all the way off the page, probably off the table as well. So, two more concepts. We want to talk about domain and range. So domain is going to be the set of all inputs. Set of all inputs. So in this case, notice how we can choose any x we want. The arrow is saying it's going all that way. It's going to go that way forever. This arrow means it's going to be shooting off in this direction, upwards. So our domain in this example is going to be an x being all real numbers. So from -infinity to infinity. Another thing we have here is range. So the domain is a set of all inputs. We can think of that as being our x values. And our range is going to be the set of all outputs. Or in other words, if I were to talk about my y values, how would I set that up as an inequality or as a bunch of these values? So in our example, notice how our function kind of stops short right at y is equal to 0, or where we're right on that x-axis, and then it turns around and starts going back towards infinity, or back towards those really big numbers. So what we can do here is actually set our y value greater than or equal to 0. So our range is saying, hey, we know our function is going to have outputs that are always bigger than or equal to 0, and we can kind of see that on our table right here. We hit that 0, but notice how everywhere else it's always going to be greater than 0. We're never going to hit a negative number. So two more little pieces of vocab. And so in our next case, what I want to do is actually show you something that's not considered a function. We've been talking about functions all this time. So let's talk about a relation. A relation is a little bit more general. Notice how in our function it says each input gives exactly one output. So maybe in this example, we could do our XY table. And I'm going to choose some X values. This will make sense in just a minute. And I have x squared plus y squared equal to 1 as my function. So even though this is a little tricky, we can use some intuition in figuring this out. We know that the left side always has to equal 1. So if I have some x values right here, we can actually kind of guess and check what this y would be. It's saying if my x was a negative 1, so we're going to do an example x equal to negative 1, we will have an input of negative 1 squaring it. And it's saying, hey, if I take a negative 1 and I square it, what do I have to add to that after being squared such that it equals 1? Well, negative 1 squared is just negative 1 times negative 1, or 1, plus y squared equals 1. So in this case, y actually has to equal 0, okay? And we can do that by checking. So 0 squared equals 1, or 1 is equal to 1. So that's good to go. So when x equals negative 1, y equals 1. But let's look at the x equals 0 case. Here I put, I'll separate it. I have 0 squared. I put in my x value equal to 0. And now I'm adding the y squared. I'm trying to figure out what this y has to be such that when I add them together, it's equal to 1. Well, 0 squared is just 0. And we have to add a number that when it's squared, we're going to get a 1. So in this case, we have two options. Our y could equal negative 1. So let's check that. And keep in mind for this, I'm kind of looking 2 steps ahead at every single point. So sometimes it might not be this obvious. It comes with a lot of practice. It comes with a lot of time to notice that sometime that certain operations are going to give you certain values. So don't worry if you're not seeing this right off the bat. You know, you're still getting the cobwebs off. So let's see what we can do with this. We'll have 0 plus negative 1 squared is equal to 1. Simplify this. This is just negative 1 times negative 1. Remember our exponents. Or 1 is equal to 1. So, y equals negative 1 works. That's awesome. But let's check out another case. Well, the more obvious one, y equals 1. 0 plus 1 squared is equal to 1, or 1 is equal to 1. Okay? So that one works as well. So look at what we have here. And, you know, I'm going to go ahead and just give this one to us to get this video done with. But we have a place where each input is giving more than one output. Let's look specifically at these zeros. When x is 0, we put it into our function. We not only get out a 1, we also get out a negative 1. So that breaks our rule. Each input has to give exactly one output to be a function. In this case, it's a relation. So it's more general. A relation is just any two values that have a connection with each other, okay? So if we wanted to actually graph this thing out, I'm just going to do a little one right here to refresh our understanding of coordinate planes. When x is equal to negative 1, y is equal to 1. Oh, sorry. Whoa, this is going to be equal to 0. So when x is equal to negative 1, y is going to be equal to 0. When x is equal to 0, y is down here at negative 1. When x is equal to 0, y is also equal to 1. So notice how we have a different representation of a function here. Notice how we have two dots stacked on top of each other. We don't have that in our parabola right here. So we have these 4 points, and this is actually going to give us a circle. So it's okay, I know I'm giving you a lot of information here. I'm pulling out a lot of ideas that you might have seen before but not have been super 100% on. We're going to be revisiting the parabolas. We're going to be revisiting circles even farther on in our school year. But what I really want you to take away from this lesson is just this idea of a function. You put a 3 in this case, goes through a rule we get out of 5. In this specific case, we actually defined our function. F of x is saying take our input, subtract 2 from it, square it, and you'll get a value for each input. So we got our table, we proved it a little bit that our function is actually giving us some outputs. We finally graphed it, got some variable definitions in there, so independent for x, dependent for y on our coordinate plane. We defined what a domain was, which is the set of all our x values or all our inputs. In this specific case, notice how we're always going to have some x values, so it's all real numbers. And our range is our set of all outputs, or all our y values. Noticing here, we're never below the x-axis, so we're always going to have positive y values. And then finally, we took a step further and kind of looked at a relation. In this case, we decided x squared plus y squared equals 1. I had a little bit of a mess up right here, but the whole idea still holds. We checked and guessed and checked some. We noticed that for x equals 0, we actually get 2 outputs, a y equal to 1 and a y equal to negative 1. And once we plot that out on our coordinate plane, we find that it's actually a circle. So if you have any questions, anything you want to have clarified, go ahead and put a comment in Google Classroom. I'm going to try to be proactive in answering these with videos. And once we get more and more into this, I'm going to cut the small talk, I'm going to cut the introductions, going to give you a few examples so that we can have some good resources for the classroom so that you can support your learning. All right, bye guys.